Let's take what we've learned so far and put it to use solving a couple of problems. So let's say we have this. Now we could just go ahead and just multiply it straight through, but one of the reasons why you learn the rules of matrix arithmetic is so you can simplify. Just like when you're used to solving real number algebra, right? If you had something like this, if I had, a times b plus a times c over a, if you knew a, b, and c, you could solve this, but you might look at it and say, well, this really is this. Which is really just this. Isn't it easier just to do this and then plug in b and c than it is to solve this? Probably. I mean, it depends on the numbers, I guess, but this is probably what you would be inclined to do. Okay? Well, we can do the same type of things here. So I look at this and go, wow, over here, I have this 4. I can factor that out. Remember, I'm going to show all the steps, but really I could do this more quickly if I left out a few steps. Factor out the 4, right? And I can then pull the 4 to the front. Well, this is an identity matrix. So I know multiplying this matrix by this just gives me back the original matrix. Just this times this, and then I can solve this. It's 4 times each of the elements. So 12 minus 4, 4, 8. Right. Now, would I have really shown every one of these steps? Not normally. I basically would have went straight from here to here normally, and then solved. But I'm trying to show you how I'm thinking about it. But remember, scalars can be pulled out. So we're not worrying about commutativity when we're dealing with scalars. If I'd had something like this, and say we had something in here, this isn't really a good example to show why I might even be thinking this, but if I looked at this and thought, wow, for some reason it'd be easier if I pulled this to the front, well, I can't do this. And that was 7 and 8, not 78. I can't do this because that's commuting or changing the order of these two things, which, as we've already seen, can change the actual answer. So this is not legal. But this is. I'm just pulling out a factor. Now, if you're wondering why that is, you could always take some examples that are generic and see how the numbers multiply through and they're carried through. Okay? So let's look at another example. So let's say I have this. So there's A, there's B, right? And I want to evaluate this expression. Right? So once again, I could figure out what B transpose is, which is easy to do, A transpose, easy to do, and then I could take the 4 matrices and multiply them together. But can we be smarter about it? Well, there's a couple things I need to remember. Matrix multiplication is associative, so at some point I'm going to have to multiply 2 matrices together, and whether I want it to be these two, or these two, or these two, I have that choice, right? And if I think that, say, multiplying the 2 middle ones together would be easier than starting with A and B, well, then I can do that if I want to. But also see I have these 2 transposes here. And so I remember this rule, right, that says that assuming we can even perform this product, which we could in this case, that if I take the transpose of A times B, that's equal to the transpose of B times the transpose of A. Well, nothing says I have to start with this and go this way. I can always go this way, which is what I have here. So this right here is really this. And you say, well, what benefit was that? Well, I have to produce AB anyway, so once I produce this AB, I just plug it in here and then transpose it. I'm still going to have to produce several products, but I don't have to multiply this times this times this times this. I just do one quick step and I've already produced one of the products that I can reuse. So that's what I'm going to do here. So AB is this. Right? So 2 times this is 0, or excuse me, it's minus 2 plus 0. We'll have 6. We have minus 1 and 8 is 7. And then we have 3 minus 4 is minus 1. And so that means now what I have is this. We're using this right here. So here's AB, which is my minus 2, 7, 6, minus 1. And this will be the transpose of AB. So minus 2 and 7, or excuse me, this is minus 1. Minus 1 is here, but now 7 is here and 6 is here. So now I produce the products. Minus 2 times minus 2 is positive 4. 6 and 6 is 36, so this is 40. And then we have minus 14 and minus 6 is minus 20. Minus 14 and minus 6 is minus 20. And then we'll have 49 and 1 is 50. And there's the answer. Okay? So like I said, this is one of those things you can carry over from what you learned with real number arithmetic and algebra, is that things can be simplified at times, and you may choose that to make your overall life easier. Okay? Of course, now to do this, we assume A was not equal to 0, but then if it was equal to 0, I couldn't even evaluate this anyway, so the simplifications don't change that fact. Okay? So be smarter, see if there's some way to simplify and make your life easier overall.